Okay guys, so in this video we're gonna walk through, well, basically the features adding rows, so let's have a look. So this is how far we've gotten so far. You can see here that I've already taken the liberty of adding some rows here, and if I click add key here, I can say foobar, and then I can say something and give it a little bit of a description, and then I can say foo, click like that, and then it's going to give me a tag of some sort. I can click and make several tags if I want to. And I click save, and we scroll to the bottom, and you can see here that now my labels here have been, or my tags have been added, my key has been added. I have this row here where it says, whatever I inputted for English, because that's the default language. And it says empty for Swedish, and then we've added another key. And that is pretty much our entire features so far. So we can now actually add, well, rows and translations and some meta information. So let's walk through how all of this actually works. We have quite a lot to cover because this turned into a bigger story than this is how it happens sometimes. I mean, you have these choke point stories where you start working and it's you need to do quite a lot of setup and like boilerplate and write a lot of stuff in order to support something that should be fairly simple. But that's where we are. So we can see here that for the Java part of the application, we've added a dependency on Hibernate Core and MySQL connector. And then finally we've added a Spring Boot starter for GPA, and basically all of these three things together. So Hibernate is a ORM mapping library, which allows us to map our relational data from MySQL to our objects that is going to run in Java. And the connector is just the interface between these two, so I can actually connect to MySQL and run queries against it. And Spring Boot started, like this package here, just helps me kind of bootstrap some of the common stuff that I need to declare, like a repository and stuff of this nature. So these dependencies I need in order to do my database, connect to my database. And I also updated our configuration for TypeScript so that our target is now ES 2015, because I want to be able to use promises and stuff like that just inherently. I don't want to compile down to ES5. Which of course means that we're not 100% backwards compatible, but hey, we're running this in a modern browser and it's not a project that needs to support old browsers. Some arbitrary small little change to CSS. I added a component called key editor. We'll touch on that in just a moment. And then I added a AppContext provider because I made the decision to, in this video series, use the native context API from React as opposed to using something like Redux. There is no, this is just a personal preference because the last video I made with React was with Redux, so now I might as well use the context API to give you both sides of that. And here is my application. As you can see here, there's quite a few changes that's happened here. We've added the key editor. We have a function called getAllTranslations that's going to go and do a network call. And we have some functions, or we have an interface called context props, and then we have with AppContext, which is a higher order function that I will touch on in just a moment. And as you can see here, when we mount our component, our app component, we're actually going to go and call getAllTranslations. And getAllTranslations, we can actually go in and look at that. We'll simply look at my translations API. So basically all I did was to declare a few fetchers for grabbing data from our server. So these are simply going to, well, in this case we have one for saving translations. So we're going to take in all of the data that we need in order to create a translation. We're going to create a body. We're going to call fetch with a request type or an object that I declared, which is just a generic, hey, this is a request of type JSON, or the content type is going to be JSON, and we're simply going to pass in an optional body, and that's pretty much it. And then we have an enumeration for the HTTP methods that we are supporting. And then we make our call and we get a response, and then we wrap that in a translation. We're going to look at that type in just a moment. And then for getAllTranslations, it's a very similar approach. We do a get to our URL and we grab the JSON. And then I have a function called validate value type, which we will look at as in just a moment as well. And then I loop over because I basically expect that the response JSON is going to be an array. I loop over all of that, and that's just going to be wrapped into a translation. Right. Let's keep on looking. So we have looked at the app, so let's look at the app context. So this is just like basically the app context, for those of you who may not know this, is just a way for us to hold state within React. So we can basically keep some type of client-side state that represents the data or the state of the application. So if we just walk through this, I have exported a interface called like the app context, and right now everything all it's going to hold is like a function for closing the key editor and opening the key editor. The key editor is this thing here. You see this little modal, so I can open it, I can click outside, I can click inside, I can do all of these things, right? And these functions are basically just there to toggle that on and off. And then I have a function called sets translation, so that when I refresh this web page, you can see that it actually keeps these rows. So what's actually happening is that when the component mounts, it's going to go to the network and call the URL that we saw earlier to translations, and the response is going to be this. This is the data that we get from the server, or from our Java server. And then all that's going to happen is that this function is going to be invoked, and it's going to set the translations. And then we have this boolean show key editor, which is the thing that toggles on and off if we actually display the modal. And finally we have, well, the translations array that just holds those. And so what we're going to do is we're going to create our context, which is going to hold all of this information, or well, give us the interface for a provider and a consumer. I'm not going to go too deep into that because that's a separate video, exactly how the context API works, but that's anyway like this is the way I use it anyway. And then I have an interface for the context props, because I'm just going to add a interface that declares, okay, these are the properties that are going to be passed into a component. And if they, I use this for extending basically, so that I can express that there is going to be a context on the properties passed into this component. That's going to make sense in just a moment. And then I declare my app state, and then I just create a context provider props as well, because the context provider is going to have some properties as well. In this case, it's just going to be children. As we could see here, all it's going to do is that it's going to wrap. Let's see here. All it does is that it wraps my app component, and that's basically why I put that there. So finally, we can go to the actual class here. So as you can see here, we're simply creating a component. And here is our state. So we set a state, and then we bind a few functions that we're going to actually pass down. And finally here in our render method, we declare an object with all of these keys and the corresponding values and functions that we want to pass in. And then we declare a context provider, which is going to take this as a value. And the way that this is going to work is that it's going to pass through all of these values that we have here to any consumer at the bottom. In other words, if I declare a context consumer somewhere within my DOM tree or my node tree, they are going to get the context object, which is going to contain all of this state, and that's exactly what I want. If I had a bigger application, and this would have been like a project that's going to be more long spanning, I would probably not have put everything on directly on this flat structure here. I would probably have segmented it, where I would probably declare an object that is named after a component or some module, and have basically an envelope pattern where each key maps to a module, and the value itself is an object with all of the configurations and states that I want to keep. And here are my methods. So open key editor is just going to set the value to true, and closing it is going to set it to false. Setting translations is, hey, it's going to take in translations and set them to the state. And then I have this little magic here, which probably needs a bit of walkthrough. If like this, don't get scared, I'll walk you through it. So basically my type omit that I have declared is a type that I use in order to be able to omit a key from an object, because what I want to be able to express is that I want to have the typing system. I want to be able to wrap a component in the provide the context consumer, so that I can actually pass a context down to that component. But I don't want to lose the types that I have declared on my component, if that makes sense. So what I want is to be able to say that, hey, all the properties that you're passing into this, I have declared on this element, or this React element, I want you to I want TypeScript to enforce that these types are correct, but I don't want to have to explicitly say that, or I want to exclude the context from that requirement, because the problem is that since basically the provider and the consumer are communicating without me explicitly passing through the context object through my entire tree, I don't have a context to provide to my component, and that's going to be a problem. So I need to declare a way of, I needed to find a way to say, all right, all the properties that you have declared on the interface, I require those, but not the context, if that makes sense. So what omit is going to do is it's going to take a type T and a type K, and that's going to be an extension of a key that is found on type T. And then that's the interface I'm declaring of the type. And then I'm going to use a pick type, which is basically allowing me to give it the type T, so the original element there. And then I'm going to give that an exclude. So I'm going to exclude something, like basically remove something from this type, and that is going to take a key of T. In other words, it has to be a key that is found a key that is found on the type T, and then just a value K, which is going to be the actual thing that I want to pick off, and that's pretty much it. So if you have a look here, we'll see here that with AppContext, it's just a function that takes in a type P that is going to be an extension of the context props. You know, hopefully this will make more sense in just a moment, but and I understand if this is getting a little bit advanced, but that's the basic idea. So I declare the properties that I want from my type, and then this function is going to take in a component that is just a type, like a component class with the type P, or rather the properties of type of P. And then finally I'm going to return a function that is going to take in these properties, and that's where the omit comes in. So it's going to take in the same properties that I have declared as being the properties of my component. And then I'm going to omit context, which is this key up here, this thing here. So that's all I'm doing. I'm basically saying, hey, give me all your properties that this component has declared, but just remove the context requirement, and then that's it. And then I return a consumer, and that's going to take in this value, which is going to be the context. And I've added a ts-ignore here just because I have this weird compiler error. I'm going to be honest with you, I couldn't figure out how to solve this one, but basically it's complaining about this value not being the correct type. So adding a ts-ignore there, so ignore there just solve that problem. But as you can see here, all I'm going to do is I'm going to take any component I get, I'm going to grab all of the properties that are passed into my component, or this higher order component, add the context as an input to that component, and then spread the remaining properties. This will make more sense once we see it in action. Well, actually we kind of saw it here with the AppContext, but anywho. Let's see here. So let's have a look at some CSS, like arbitrary CSS changed, badge button, some arbitrary changes here as well. And now we are on my key editor. So the key editor is going to be this component here, my little modal, which is super fancy. And as you can see, we have some imports. Here I am declaring my properties for this editor, the key editor, and here you can see that I'm actually extending the context properties, and that's exactly what I want, because I am going to require the context or the context state in this component. So I declare my properties, and I bind my submit and my on close so that I can submit and I can close, and then I have my render function here, which is basically going to check if I've said to this component that, hey, show yourself. If it's true, I'm going to, if it's false, or rather I don't want to show this component is simply going to return the return null. So this component is, it's not actually going to be rendered. Otherwise it's going to render out all of this good stuff here. And this is basically just the editor itself with the form, the header, some buttons for closing and stuff of this nature. Hopefully this makes sense to you. And here's my on close, where I'm basically, you know, if I click outside or I click on the X or something like that, I'm going to just close I'm going to call the context on close editor, and remember what that did. It's just going to set the global state, the show editor boolean value there. It's just going to toggle that to false instead of true, and that means that, as you probably can guess, that's exactly what I'm passing in here. So this is going to be falsy when I click the X, and that's why it goes away. And then we have my submit here, where I basically just expect that this is on the form, which is going to be passed in it's form element basically. And then I just prevent the default behavior, which is important when you're doing this with forms, because otherwise the form will be submitted, and I don't want that. And I also stop the propagation of this event, so nothing leaks out from this. And then I convert my target to an HTML form element, because that's what it actually is. It's just that it could be inferred. And then I go to my form and I just extract the values of my fields. And for the tags value element, I basically just, which is this little fancy component here that holds all of my nice little tags, I'm simply going to extract out that value and split it, because that's just a concatenated string with a comma separated string, and then I'm just going to split on those commas and filter out any empty tags I have, and that's going to be my tags array. And then finally I'm going to call save translations, which we saw earlier is just going to send a request to my server and persist all of that good stuff, right? Then I'm going to get all of my translations, because they are, I'm going to the database, and then I call my context function called set translations, which we saw earlier, just going to set the translations, and then I close my editor, and finally I just return false because I'm in a form, and that's about it. And here you can see the with AppContext thing, that function in play. So basically I've created this component, and all I'm doing now is that I'm wrapping that in this with AppContext, which is going to save me the hassle of having to declare a consumer manually. So it's just going to create another component around it and return that component, and that's my input, and out comes a component that is going to inject my context for me. So that's pretty handy. And yeah, that's about it really. We can look at the actually look at the form fields here, which is not super interesting. It's just the fields themselves, where you have your input for the actual key, and then you have the base language, and then you have like a description, which is the text area, and the more advanced component, which is the key editor form row, or the tag field basically. We're going to have a look at that as well. So the form row is just a bit of a time saver for me, so I simply wrap these divs here to save a little bit on space. I didn't want to duplicate all of that, because it's just a row within the form. So that's just a little bit of a convenience thing really. The tag field though is a little bit more advanced, which is basically this thing here. As you can see here, I can actually add tags and I can remove them. And yeah, this basically is this component. So in order to achieve this effect, I've declared my interfaces, and here is my component. And as you can see here, we have a few functions, so I'll just walk through this. So basically what it is a list, where the first element is my tag label, and then I have my tag field list, which is, well, basically the remaining list elements, or rather each element within that list. Let's actually inspect this. It might make more sense if I inspect it. So here's my list. The problem is that in order to achieve this effect where I actually get these tags, I need somehow, in some way, I need to make this a dynamically growing and shrinking element. So if I click inside of this element here, what's basically going to happen is that I'm going to select the input field, which is this thing here, as you can see here. And when I enter something like this, and I just click, I just click a colon or a space or something like that, I'm going to inject an element before the element, like the list element that actually holds my input field. So you can see here now I actually added something to this list, and that item is, well, basically this. Hopefully that makes sense to you. So if I click and remove that element, you see that there's nothing in that element anymore. So it's like the only thing that's going to be there is this little tags label that I have as a placeholder. So it just kind of fakes being a placeholder, if that makes sense. So clicking KKK, and that's or QQQ. And that's about it, really. So this is the best way I know anyway how to achieve this effect of having tags. Anywho, so that's basically all of this logic here. I mean, there's tons of this stuff. I don't know if all of this is all that interesting to you to look at, because I'll just look at the logic if you really want to. Because I mean, it's a fancy component, but we really didn't have to make it this elaborate. I just kind of did it because, hey, that's the way it works in the actual application. And here's my field list, which we saw earlier. Well, that's just the list with all of the different elements or the tags themselves. And finally, we have our tag label, which is just this convenience wrapper, as we saw earlier, for just like that tags thing there. So I think we kind of covered all of this. Now let's have a look at my translations list. Let's have a look at that. So the translations list is basically this element here. So all of this good stuff here. And basically all that we're going to do is that we are going to declare this list, and then we can see here that our context comes in again. So we wrap this in with AppContext, this component. We get back this higher order component that injects the context, and then we grab it from our properties, and here is our translations, and then we just loop over them, and we create a translation row. And that's pretty much it. So let's look at the translation row. So here we can see that the translation row now has this little translation value list and all that good stuff. We can actually look at it in the diff, because that may make it a little bit clearer. As you can see here, originally it was just hard-coded stuff, and now it's actually dynamically being inputted. And for the translation row, it's a very similar situation where, okay, this was now it was hard-coded. Now we actually have a interface for our props, which is going to take in a translation, and then we're simply going to pass in the tags, the key, and the description from this translation. And the value list, it's just going to be the list of translations that we actually save, because remember, we have Swedish and English, and in the future we might want to add support for more languages. So that's about that. And let's see, we can actually look at the meta bar again, which, well, as you can see here, there's a bit of a change here as well. So now, if we go to this actual file here, let's go to the file, we can see here that we still have this random color, which is, great just for kind of making things pretty and nice. And now we have declared our interface, translation key, tags, and description. We pass all that good stuff in, and now we're just going to loop over the tags instead and create a list item per tag. And yeah, that's about it, really. So nothing super exciting that's happened here, but hey, there's quite a lot of code, so yes, you can imagine not everything can be super exciting. So apart from that, we also have the value list, which is going to be this component here. And as you can see here, it's also just hard-coded values over to dynamically rendered values. You can actually look at the whole file here. So we're just passing all that good stuff in here to the value list, and then finally the row has changed extremely little. It's just taking in the language like as a property now. And that's about it. And then here we have some arbitrary small CSS changes to kind of just make things nice and pretty. Here we have our add key box, which is what we saw earlier, which is just going to take in this context as we saw earlier, where I need to, when I click this button here, I actually need this to open, and that's this button, this function here. And once again, we wrap it with the AppContext so we can actually get that injected. And then we have our tag filtering box, which is still, I just made some small modifications here to this. There's nothing super fancy going on here. We're going to look at that at a later stage, but I just wanted to keep things fairly consistent, so I updated that a little bit. So the tag name, same thing here, just a few updates for the types. And then we have our translation bar where, well, basically we just added in, so instead of having a hard code as 0 there, we're going to pass in the number of keys. And that's just basically the length of our translations, right? So let's look at our API utilities. So you notice this function I showed you earlier, which is called validate value type. And the reason why I have this one is because one of the main problems with writing client-side code is that the server lies sometimes. And when the server lies, your application breaks. So what I like to do is that I like to create a small runtime validator of some sort. This one is fairly simple. I could make it much more elaborate, but now this is just a simple check that allows me to check the incoming models against the type that I'm actually expecting. So I declare my type. I expect there to be some type of value, and then I declare a default type of the same type that I expect this to be. And then just a key name, in other words, the name that I expect this key, the key that I expected, or the name of that key. And then I just get the type of these two values, compare them to each other, and if they're not equal, I'm simply going to console out an error saying that I didn't get the thing that I expected, and then I'm going to return the default value, and then and otherwise I'm just going to return the value. And this helps me just make sure that I'm informed if something unexpected comes from the server. So if I change my data structure somehow, this is going to alert me and tell me that, hey, the client expected this, but you're getting that. And that's a very handy way to quickly figure out if something has broken when you make a new deployment into production. And we already looked at that. We already looked at the translations API. Let's look at the translation type. So I've declared my own model for the client side, where I basically just declare, well, an object that's going to hold all of my translations, and this is just going to take in an incoming translation, which is like the thing that is actually, as you saw earlier, because remember, TypeScript will help us with all the type checking as long as we can trust the type that we actually get. And we can trust everything we wrote ourselves in TypeScript, but we cannot trust what's coming over the network, because there's no way for TypeScript to actually know what's going to come in over the network. I mean, it's just JSON, and when that happens at runtime, it's not possible for the compiler to know, we can't really know what that is. So that's why I'm doing this, where I basically do a runtime check before I construct my object, because if this step passes in my application flow, I can trust everything thereafter, which is great. And then I have my translation text, which is just going to be the holder for like the actual translation. So that's going to have an ID, a text, and a language. And this is pretty much the mapping for that. Cool, so that is pretty much all of the client-side code. Hopefully you're still with me. So let's have a look at the server-side code. This may actually be nicer if we're looking at that in Eclipse, because there's quite a lot of stuff that's happened here. So let's start by looking at our controller. So I've added, as you can see here, a service, which I call translation service, and we have a get and a post mapping, and these have now been updated. So if a request comes in for getting my translations, I'm just going to go to my service and get all of my translations. If there's a post, I'm going to expect there to be an incoming translations type, and this is just a simple object that maps to what I expect that's going to come from the actual, from the post. And this is generally, this is a good practice to follow if you can, where you have the concept of your own model, this thing that makes sense to your system, and then you have what you call the incoming model, and that's usually what's coming from the external party, because it's very often where if you do integrations and stuff like that, the shape of the data that you're going to get from a third party very rarely maps over to your own model, so it's good to have that in-between layer, which is your incoming model, and this is just something that represents what the external party is going to send to me, and then I simply map that over. You'll see that in just a moment. You can see here immediately that I have my own translation type, which is going to take an incoming translation, and then it's going to return a translation. And then I save that translation. Easy peasy. So let's look at my service. It's a very simple service. And we're using, basically just declaring it as a service, and then we use dependency injection. AutoWire is going to, that's basically what Spring is going to help us with, or Spring Boot in this case. It's going to inject my repository, and in the previous example, it's going to inject the service, so I don't have to instantiate it myself. That's going to be taken care of at runtime. And a repo is just it's just the actual data persistence layer, and that's one of my favorite features of Spring, is that I don't have to declare my own repository. I don't have to write all that boilerplate code myself. I can simply extend the GPA repository interface and give it the types for the value that the entity that I actually want to do the mapping for, and the ID, and in this case it's just going to be a long, and then the rest is going to take care of itself. So I'm going to get all of these nice methods that I can use here. So like find all. I mean, I don't know how many times I've had to write this code myself, and it's very nice that this code can actually be generated or inferred by the framework. And the same thing goes for saves translation, so nothing super fancy going on there. So what else do I have to show you? Yeah, actually I should show you the actual translation type. So this translation type here is basically just going to be marked up as an entity. So JPA can well, basically this is a JPA annotation that is going to declare this as an entity. It's something that we're going to persist to our database. And then we declare our table, we declare our ID, and that's going to be a generated value, because hey, we just want this to increment every time we add a record, and that should take care of itself. And a string that we call translation key, and then we have a mapping between one-to-many mapping between us and the translated text, because this is not a full-fledged entity in of itself. It's just something that we want to be in an external table. It's just a list that we want to join in onto this model whenever we access this model, because this is the model. I mean, this is like translated text is just a child or like a subtype or a sub-entity, whatever you want to call it, of this class, so we don't really care about keeping that as a full-fledged entity. So by doing this, we can basically just say that, all right, whenever I load a model for translation, just join on all the related translated text types. And then we do the same thing for translation tags. And here is, well, the default constructor, because that's needed in order to actually allow the ORM to work without us, or Hibernate to do its job without us having to fix stuff or do it ourselves. And as you saw earlier, I have this other thing here where I take in an incoming translation, and I basically just go through and I map all the incoming stuff into my model. And yeah, that's about it. This is the instantiation. And then I did a little bit of magic here, because the thing is that since I declared the tags to be an object, I don't want to send an object to my client. Because the tags doesn't need, like the translated texts, they need to have things like language and the actual value, because I need to know which language I'm actually showing. So what text is associated with what language. But the tags, I mean, that's really just text. But because the tags need an ID and needs to be in an external table, I just do this, where I pretty much just create a little secret getter that is going to map over my tags to just the text value that they represent, because I don't need the whole object. Right, and well, we can look at the translated text. It's not a super fag, it's just a podio, a very simple podio. And then we have our tags, also a very small little podio. And translation utilities is just a few utilities that I created to validate that something is not null and validate that my string is of a certain length, because I have these small little rules that I want to enforce. And yeah, that's about it really. And then finally, well, our application configuration file, which is just going to be, well, this is just for development purposes now. This is our configurations for our running MySQL server, which I'm running in Docker. Let's see if I still have that up here. Yes, let's see here, Docker PS. Yeah, and as you can see here, it's just running for development purposes. In the future, we are going to update this to make this into something more production worthy. And that is, well, it's not everything, because I still need to show you, language is hopefully fairly self-explanatory. And this thing that I wanted to show you though is this thing here, which is the REST exception handler. Because one thing that will happen sometimes is that somebody's going to do something they're not allowed to. So I haven't created any error handling for this, but if I click, let's take a look at network, and I click just save like that, you'll see that I get a 400 back, and the message I get is key cannot be empty. And that's where this translation utility, or the utilities that I created can come into play, where this is going to throw an illegal argument exception because I want to be able to express that something went wrong with the input that I'm getting from the external system or from my client-side code. And to handle that, I declare a exception handler. Some people have different strategies for this. I like to have a global one because I want to have one single place where all errors, regardless of what they are, is being handled. That makes it very simple to keep track of what's going to happen if you throw a certain type of exception. And you can of course subtype exceptions and make them into something more custom if you want that. So this is a very efficient way, I think, to just declare a exception handler that will handle kind of all the things. And then I have my error response, which is this simple thing here. Cool, so that should be everything. Quite a lot of stuff happened in this video, but at the very least we are now done. So we can go and say it like that, and then we can have a look at removing rows, which is going to be the next video. Have a great day.